When I completed my training and the problem of organ shortage became my problem, then I decided, well, maybe the thing to do is just make organs. And then we wouldn't have to rely on a supply that would never meet the need. And so with those beginnings in the 1980s, with my good friend Professor Langer, we began down a road to try to understand what the problems might be, and then go on to try to actually design and build a whole organ.
A pretty lofty goal. But his colleague Bob Langer, an MIT chemical engineer, was no ordinary professor, and his specialty was building dissolvable plastic structures that harmlessly disappear after giving new cells a place to grow, or as they are called in the world of tissue engineering, biodegradable polymer scaffolds. Soon Vacanti and Langer were onto something. But what actually propelled them forward didn't come from a lab. It came from the sea. It was 1986, and Dr. Vacanti was on vacation in Cape Cod. He had never stopped pondering how to build a liver. As he sat on the jetty watching his family play, he saw some seaweed. A major breakthrough in tissue engineering was about to happen.
I could see seaweed waving through the water. As the water moved, so did the seaweed. And so it struck me that the seaweed was answering that question.
Dr. Vacanti's question was how to keep alive and grow the cells of tissue like cartilage and eventually the liver. The answer was in the shape of the seaweed, which allowed nutrients to reach a large number of cells deep inside and on its surface. The branches of seaweed were the key.
The fundamental repeating unit in nature for all living systems that are multicellular are branching systems.
Like seaweed. Dr. Vacanti immediately phoned Professor Langer, and they began working on a dissolvable structure that would look and act like the seaweed, branching out and supporting life. Before long, they were seeding their dissolvable plastic scaffolds with living cells.
This did exactly as the seaweed in the water did, and it allowed the fluids to percolate through it and keep much larger, thicker masses of cells alive while they formed new tissue and laid down their own matrix.
When they put these cell factories into bodies, blood vessels would grow into them, providing even more support. And eventually, the plastic or polymer scaffolds would harmlessly go away.